Hi, I'm Fraser Lewis. I'm from the Fawkes Telescope project, which is in Cardiff in South Wales, and I'm also part of the FTP Europlanet group, which is based in Germany. And I work with the National Schools Observatory in Liverpool and the Open University, which is a distance learning provider in UK. Today, I'll be talking to you about a project we've been working for about 2 years or so on now called Gee-Whiz Astronomy Modelling, or GWAM, or GWAM. And it's a worldwide online club, which we hope opens doors for our students to astronomy research. So, like I say, it's called Gee-Whiz Astronomy Modelling, and we are a group of educators and students. We are from all over the world. We're from the USA, Wales, Chile, India, Colombia, and even Argentina as well. And we meet once a week. We meet round about 6 or 7 p.m. for myself in the UK. So about 18 or 19 UT on Friday, depending on where we are in the year and how everybody's daylight savings time and so on is going on. We chat for an hour, we talk to our students, we see how our students are getting on, we give them ideas, they give us ideas, and then we meet again a week later and see how people are making progress. There is a link there, or a little image on the right hand side, which describes something that we're developing at the moment. And I apologize, it's in Spanish, which probably is quite useful for many of you and slightly less useful for others. But it basically defines the sort of the four stages of educational material, if you like, that we are developing for our students based on using free and easily accessible pieces of software such as Stellarium, such as Salsa J, based on our use of Las Cumbres Observatory telescopes, and based on some slightly more advanced things that we're doing with some of our students. There's a web link at the bottom there. I would encourage you to have a look at that, and that's in both English and Spanish. You can have a look and see the material that we're developing there. Like I say, it brings forward a whole series of students and teachers. We are a group of, sometimes 5, sometimes 10 of us, and we are just plugging away at different bits of astronomy and developing some ideas and some modeling type activities. Modeling, I guess, is the American term. In the UK or in Europe, we often hear things like research type activities, inquiry based science education. All those terms, I appreciate they all have their own individual meanings, but all those terms sort of encompass a little bit about what we're doing. And we are very grateful to the people that are listed on the slide there, without whom we would be making no progress, both in terms of the teaching and the students. And sometimes the distinction between the two becomes fairly difficult to spot. I include there on the right a graph of the kinds of activities that we're doing. This predates GWAM by a few years, but this is an exoplanet light curve, so a transiting exoplanet, a planet orbiting across the face of its own star, not our sun. And these data points represent the change in brightness as the star dims with the planet passing across its face. So you have time on the x-axis and brightness on the y-axis. And this is a fairly typical transiting exoplanet. It's something that we've been working on with our students on GWAM for a couple of years or so now, and we are producing light curves that look similar to this, and some light curves that look a little bit different, and we are collectively scratching our heads and trying to work out what it is we're seeing. One of our students in particular, and a couple of our teachers, have been involved with developing some resources around program or set of pieces of software, if you like, called TOPCAT, which you may have come across. It's used by professional astronomers. There's a lot of really clever stuff on there. I've think Microsoft Excel on steroids. That's really probably a fair description. It is extremely powerful, but by its nature, of course, it takes a little bit of getting used to. One of our students, however, has gone away and worked on TOPCAT in her own time, and gone way further than I think we ever expected our students to go. And she's used the data release 3 DR3 from Gaia. So Gaia is the European Space Agency mission that is mapping our Milky Way. And she has used the data that Gaia produces to produce a series of color magnitude diagrams. If you prefer the term Hertzsprung-Russell diagram, they're kind of interchangeable. And she's been doing that on a group of open clusters. So this, in a sense, is in addition to the more conventional technique you can use, such as a Las Cumbres Observatory telescope, to take some images of an open cluster, and you can use photometry software such as SalsaJ, such as Mercalli, such as AstroImageJ, and so on. You can use that in conjunction with something like Excel or even Python to produce color magnitude diagrams. So she's comparing what TOPCAT and Gaia produce with what you do in a kind of a more manual, I suppose, old-fashioned type way. Here are a couple of screenshots from a paper that she is currently working on. This is our student Isabel Martinez, and she's working on a paper here for the Astronomy Education Journal. So in a sense, we're not really reporting the science. We're not reporting the actual physical results of the open cluster. What we're trying to do is present some results of the activity, how we go about finding an open cluster, visibility using the telescope, downloading the data, and then comparing that with what you get from TOPCAT. In the case here of the two images, the one on the left is a sort of an RA index, so a map, if you like, of the area where the stars are, and it's the sort of grey oval towards the bottom right of the image that we sort of focus in on, and then we can plot the colour of the stars against the brightness of the stars, and that produces this very obvious blue line which represents the main sequence of stars as we might expect. So here's an image of Isabel, and I'll spare you reading the text that's actually on the screen at the same time, but this is an image of her having won a competition in Chile based on the science that she was doing, science fair, and then going on to represent her work and her country in a further event in Mexico. So we're extremely proud of one of our students here, and are always every week blown away by what she's come up with from the previous week when we last spoke to her. By way of advertising, slightly shamelessly, but hopefully not too shamelessly, some of the work that Isabel and some of the other students have done are based on activities that I've created prior to being involved in GWAM. And one of them is an IBSE type activity, so inquiry-based science education again, looking at type 1a supernovae and looking at the light curves they produce and looking at how that ties in with the work done by people like Hubble almost 100 years or so ago to look at the age and expansion of the universe. So quite an all-encompassing project there. It's around 20 web pages, and this was created a couple of years ago. And again, there's a web link at the bottom if you're interested to follow that up. That follows on from one that I did a couple of years earlier again, which you may have heard of from previous talks. Hopefully some of you have at least have come across this concept. Again, looking at open clusters and producing a whole load of data that we've uploaded online of open clusters with all the activity, all the background knowledge you'd want to have for doing photometry, for understanding what open clusters are, understanding what the main sequence is, and so on. And the encouragement there, as we found with our GWAM students, is to give them ownership of the data. So not just for them to play around with our data, but to go out and find suitable targets and go off and find targets of their own, take data of their own, and do the same analysis. And that, I think, gives them an awful lot more ownership of their project than just working on somebody else's data. It's a little bit of a leap into the unknown, as you might imagine, and sometimes you have to sort of take a deep breath before letting them do it, but it seems to be paying off in many ways. If you are interested in what I've been talking about today, or if you would like to find out more about Gee-Whiz, please do come and contact me by email, drop me an email. We are always looking for new, I was going to say victims, that's probably clearly not the right word, so let's not say victims. Let's say students. We're looking for new students and teachers to dip in, either as participating in our weekly meetings, which are, a little bit more advanced, but also looking at these new steps of the 4 steps that we're developing for students to progress at their own pace through very gentle astronomy through to doing these sort of independent projects by themselves. Thank you for your time, and I look forward to speaking to some of you in the roundtable session.